Hey everyone, Mr. Hauk here. In today's video, we're going to be looking at solving whole triangles of any kind using either the law of sines, the law of cosines, or a combination of the two. Let's go ahead and get started. So throughout this unit, we spent quite a bit of time looking at the law of sines and the law of cosines individually. We saw that the law of sines, which is provided right here, can be used either when we're given a triangle with two angles and a non-included side, a triangle with two angles in the included side, or a triangle with two sides and a non-included angle. For the law of cosines, we saw that we can use the law of cosines when we're given a triangle with all three sides, or when we're given a triangle with two sides and the included angle. Now, as I was saying a moment ago, the problems that we've been looking at have been tailor-made for law of sines or law of cosines, and we knew which of these two laws we were going to use based on the day that we were, working on those problems. What we're going to do now is we're going to look at problems where we're not going to know, or we're not going to be told, rather, which of the two laws that we're going to use. We're going to have to decide that for ourselves. And you're also going to see, specifically in examples 2 and 3, that we can actually use a combination of the law of sines and the law of cosines to solve problems as well. Okay, so let's go ahead and get started. Let's look at these examples. Here's example 1. Notice that in example 1, we have an angle, side angle triangle. And when we look at the two laws here, angle, side angle, we have to start with the law of sines. So when I'm looking at this problem, well, what we're going to need to do is we're going to need to find that missing angle first, angle C. So step 1, the measure of angle C is going to be 180 degrees minus the measures of the other two angles. We get that the measure of angle C is 75 degrees. Now that we have the measure of angle C to be 75 degrees here, we can start finding either side A or side B. I decide to go ahead and find side B, so I set it up as the sine of angle B over side B equals the sine of angle C, which we now know to be 75 degrees, over side C. Plugging in the pieces, we know that with law of sines, we're going to go ahead and cross multiply. So B times the sine of 75 equals 28 times the sine of 41. Divide both sides by the sine of 75 degrees, and we get that B is going to be equal to 19.02 meters after we round it to the nearest hundredths. So at this point, we now have angle C, we now have side B, and all we really need to find is side A. Now, if you wanted to get technical, we could actually use the law of sines or the law of cosines, because now that we have angle C and we have side B, we have enough information for law of cosines, which would be side, angle, and now we have this side. Or we can just keep using the law of sines like we've been doing. Me personally, I prefer the law of sines. I think it's a little easier to set up. I think they're quicker and easier to solve. So I'm going to go ahead and find side A using the law of sines, and I'm going to set it up as sine of angle A over side A equals sine of angle C, which we know is 75 degrees, over side C, which we were given as 28 meters. Again, making sure that we cross multiply and solve, we're going to get that A times the sine of 75 degrees equals 28 times the sine of 64 degrees. Then we'll divide both sides by the sine of 75 degrees, and we'll have our measure for side A, which would be 26.05 meters. But again, I want to reemphasize, we could have used law of cosines to solve for A using side angle side. This side, this angle, and this side B, which we had just found at that point. So if you wanted to use the law of cosines, you could have. Again, I prefer the law of sines, when it's available at least. All right, let's take a look at our second example. Here in the second example, we see that we have a triangle and we're given the three sides. Now, knowing that this is a side-side-side triangle, we have to use the law of cosines. It's our only option at first. So we're going to use the law of cosines, and also don't forget that when you use the law of cosines on a side-side-side triangle, you want to solve for the largest angle first, which is across from the largest side. So with 30 being the largest side, we want to go ahead and solve for angle A first. Since we're using the law of cosines, I'm going to set that up as a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Again, we're doing this because we're looking for side A, we're looking for angle A rather, and this is the only law of cosines equation that is going to have angle A in it. Plugging in the pieces, we know A is 30, B is 20, C is 17. Do a little simplifying here, so we can see that 30 squared is 900, 20 squared plus 17 squared is 689, and negative 2 times 20 times 17 is negative 680. Through the simplifying process, we know we would subtract 689 from both sides. And then after that, we would divide the negative 680, and then we would take the inverse cosine. So I went ahead and did all those steps in one. Here's the 900 minus 689. Here's the divide by negative 680. And here's our taking the inverse cosine. And this is going to give us that the measure of angle A is about 108.08 degrees when rounded to the nearest hundredth. So here's where some problems can get a little bit interesting. Over the last couple of lessons, we've continued to use law of cosines to finish these kinds of problems. But now that we have measure of angle A to be 108.8 degrees, we can actually use the law of sines if we wanted to. Because the law of sines, say that we had this angle like we have now, well, you could use a side-side angle, and you could use the law of sines to solve this triangle from here. So we could use the law of sines or the law of cosines. Now, if you're the kind of student that really just doesn't want to deal with ambiguous cases, use the law of cosines. You'll be perfectly fine. If you check your triangle real quick, so notice that this is, we'll just say it's 108 degrees. Well, if we wrap around from that angle to the side across from it, since this is an obtuse angle and the side across from it is bigger than the sides that we go through, you'd only have one triangle. So you're not going to run into an ambiguous case in this particular example. So since I know I'm not going to run into an ambiguous case, I'm going to use the law of sines because I think it's easier to set up. So the way that I'm going to do it is I'm going to say, okay, well, sine of angle A, which we just found is right here, 108.08, over side A equals sine of angle B, which is what I'm going to try to find, divided by side B. Oops. Okay. Again, cross multiplying and solving, we can see that 30 times the sine of B is going to equal 20 times the sine of 108.08 degrees, and then we'll divide by 30 and take the inverse sine. This is going to give us that the measure of angle B is about 39.33 degrees. But again, I have to stress this again. If you choose to use the law of sines, be careful with the possibility of ambiguous cases. Notice that when I went through and decided that I could use the law of sines, I made sure that I was only going to have a triangle with one solution. And it kind of goes back to the notes that we looked at in a previous lesson. So if you pull up that little chart where we were talking about the potential ambiguous case scenarios, just make sure you don't fall into like that two triangle scenario. Okay. Thirdly, and this is, now that we have two different angles and we're looking for the third angle, we know the third step is always going to be the easiest. The missing angle is going to be 180 degrees minus the two angles we know, and that's going to give us our missing third angle as 32.59 degrees. Okay. All right, example 3, our last example in these notes. We're given that B is 14, C is 23, and the measure of angle A is 107 degrees. I'm going to go ahead and construct a picture here. You should always do that when you're not given a figure. And notice that we have a side angle side triangle. And if we have a side angle side triangle, we have to use the law of cosines. So, law of cosines comes first. Now, when you have two sides already, you want to go ahead and start the problem by finding the third side. So I'm going to set up a law of cosines equation to find the third side, which is side A, across from angle A. So I get A squared equals B squared plus C squared minus 2BC times the cosine of A. Plugging in the pieces, we don't know what A is, that's what we're looking for. We know B is 14, we know C is 23, and we know angle A is 107 degrees. Taking the square root of both sides, we're going to get the side A is about 30.22. Okay, so once again, we now run into the scenario where, we need to start finding angles next, either angle B or angle C. And you can either use the law of sines or the law of cosines. The reason you can use the law of sines is because notice, with side A now, we could have a side-side angle or a side-side angle, no matter how you look at it. Again, you want to make sure, though, that you don't run into any ambiguous cases. For this particular example, again, we kind of lucked out. If we look at this side, 30.22, look at the angle, we can see that the side across from the angle is bigger than the angle that's on the way, or the side that's on the way there, this being 23. And this is an obtuse angle anyway, so you know you're not going to run into a two triangle scenario here. So because we're not going to have any problems with ambiguous cases, I'm going to use the law of sines. Once again, if you don't want to risk ambiguous case at all, just use law of cosines. You won't run into it. But I'm going to go ahead and use law of sines. I'm going to say the sine of angle A over A, which we know to be 30.22, equals the sine of angle B being what I'm going to try to find, divided by side B, which is 14. Once again, we know with law of sines, let's cross multiply. We're going to get that 30.22 times the sine of angle B equals 14 times the sine of 107 degrees. Divide the 30.22 and take the inverse sine, and we're going to get that the measure of angle B is about 26.30 degrees. Lastly, we have two of our angles now. Third angle is always the easiest to find. We take 180 degrees, subtract the two angles that we know, and we get that the measure of angle C is 46.7 degrees. So that's how we can use law of sines and law of cosines in the same problem. Once more, I'm going to reiterate the fact that if you really don't want to fall into the scenario where you might have to deal with ambiguous cases, if you have law of cosines and you started that way, just keep using law of cosines. You'll be perfectly fine.